Good morning and welcome to this online seminar with the name Is Your Packaging Ready for the Future? I'm Niklas Järlevik and I'm Head of Media Relations at RISE, and I will be guiding us through this coming hour. And a few words on RISE, if you're not familiar with us. RISE stands for Research Institutes of Sweden. We are a state-owned research company with 3,300 co-workers all over Sweden. And innovation and research in all sectors of industry and society is what we do. And if you're interested to learn more, please check out our website at ri.se for more information. There will also be a possibility for you to ask questions during this hour. There's a Q&A section in this online meeting. We will not be able to answer them during the meeting, but all of you will get answers after. Yes. And our focus today, of course, is on packaging and recycling. And we will start this hour by welcoming Ann Lorentzon.
Thank you very much.
Welcome, Ann. You're project manager at RISE. Yes, and you will give us a first introduction to this subject.
Yes, thank you for that nice introduction. Yes, my name is Ann Lorentzon, as my colleague that said, and I have been working on sustainable packaging since the original packaging directive was published in 1994. I will try to give you a flavor of what I think is needed to increase the packaging recycling, which are very actual just now. We are all familiar with the proposal for new packaging regulation, the Packaging and Packaging Waste Regulation, PPWR, which will probably soon be voted through and come into force. It is a comprehensive piece of legislation aimed directly at packaging that can be seen as one of the many pieces of legislation coming out after the Green Deal. One of the more challenging new requirements of the PPWR is to enforce packaging recycling. While the old directive mostly is a target for recycling, the new regulation also requires packaging to be designed so that it can be recycled. The PPWR states that non-recyclable packaging will not be allowed to be placed on the internal market 2030. This means that design for recycling will be compulsory and package will be categorized according to how recyclable it is. More recyclable packaging will be rewarded with lower fees. In addition, to create circularity and increase the market for recycled material, new packaging will also be required to will be made for from recycled material. Plastic packaging has target values for the recycled content. To achieve all these requirements, cooperation throughout the value circle and expertise in several different areas are required. Last year, RISE conducted a survey in which we in-depth interviewed 14 organizations, companies, authorities, and academia to find out what the biggest challenges are in achieving increased packaging recycling. Of course, a lot of results come out. But in summary, there are three main areas which industry and society need more knowledge to improve the possibility to increase recycling. These three areas are design for recycling. How do we design and manufacture packaging that are recyclable without losing any of its necessary functions? Next area is how we can increase collection by getting consumers to contribute more. For example, here in Sweden, over half of all plastic packaging are considered to be thrown away with the regular household rubbish instead of being sorted out for plastic recycling. And the third and perhaps more challenging area, how do we get sufficient quality of the recycled material so that it becomes a real substitute to virgin material? Here is also the question of safety. How do we ensure that we not get a lot of nasty substances in recycled mass? And how do we ensure that food packaging remains safe? As we can see, there's not just one problem to be solved. To increase recycling, we need to work in several areas and also in several different levels. Of course, it's not just a technical solution that are needed. We also need to be able to evaluate and understand the system. RISE has expertise in all of these 3 levels. RISE is fundamentally a technical institute, so we are familiar with the technical problems. We have material development, we know the packaging functions, and we have research in recycling. But we have also extensive assessment expertise. In addition to all our testing labs, we have lawyers to follow EU legislation and also experts in specific laws such as food content or digital product passports. We also have sustainability expertise that can evaluate packaging from a sustainability view, including using LCA tools. And we have people working on system thinking, how to create successful circular business model, and what packaging strategy do I need to be prepared for the new requirements from both legislation and consumers. More specifically, RISE has expertise in a number of areas along the value chain. Of course, we have packaging expertise. We have a packaging center with expertise that understand the various functions of packaging. And we have access to a material and distribution testing laboratory. We know recycling. We use our test and beds and pilot facilities in our research and development. More about in later presentations. We have an extensive material development, mainly in fiber-based and polymeric materials, but also in new materials and barriers. Using our expertise in lab in microbiology, toxicology, and chemistry, we can do qualified risk assessment of the recycled material. Combined with the expertise in food content legislation, we can do solid assessment of food packaging. We can evaluate design for recycling and packaging and collecting logistics. And we have research in consumer perspective, and we perform various consumer surveys. We also have a sensory perception lab where a trained panel can evaluate odor and taste of materials. But last but not least, as I said before, we also have a system approach. We know business system, traceability, legislative monitoring, and we also participate in various standardization committees. As you probably understand by now, it is my conviction that the way forward towards increased recycling is through more cooperation and involvement of different competences. I see it's a great advantage that we have all this expertise and equipment available under one roof at RISE. We are pleased to be able to offer all these resources in continued collaboration with old and also new customers and organizations to improve at all stages of the value cycle, towards increased packaging and recycling. And with that, I would like to thank you for listening.
Thank you, Ann.
Thank you.
I noticed that you said value circle, not value chain.
Yes.
Do you think we are there yet? Do we have a value circle?
We need to come there, so we need to work for that. We need to use our materials more than once, as we have done before.
I guess that's what we will be talking about today.
Yes.
Yes.
For sure.
Yes. And we will move on in our schedule, and we will listen to another co-worker at RISE, Anna Sjöstedt, who is a researcher. And Anna, I see you there. Good morning.
Yes, good morning, everyone.
Morning.
So my
You
name
will be
is...
talking about recycling of paper packaging.
Yes, that's right. So my name is Anna Sjöstedt, and I'm working as a researcher. And I will talk about paper packaging recycling today. So next slide. Yes, so paper packaging represents about 40% of all packaging material in Europe, and approximately 80% of all the paper-based packaging is recycled today. And the paper-based packaging can be difficult to recycle, and that will result in low yield of the recycled pulp. And as Anna already mentioned, we need to design the packaging products in a better way to increase the how much is recycled, and the packaging also needs to be better sorted, and we also need to take care of all the material streams such as the reject, and also to be aware about the new legislation that will require increased use of recycled material. Yes, the next slide. And here again, I also would like to talk about this illustration of the value circle. And again, emphasize that all of the different steps here, starting with the raw material, if it's from the virgin pulp or recycled pulp, producing paper and board, we will add some kind of functionality, for example, a barrier to the packaging, and then in the end you will have the packaging ready. But it continues with the distribution, branding at the retail, and in the end at the consumer, where the consumer needs to help out to sort the packaging. The sustainability, it could be to evaluate the LCA, and again, we need to keep an eye on the regulation and new legislation. And in order to increase the recyclability of a paper-based packaging, all these steps are important. We all need to contribute with knowledge within the different areas to design a new packaging and follow up how that can be recycled. Yes, and next slide. And I want to take the opportunity and highlight research questions that we would like to focus on in coming research project, the bioeconomy research program, and within the recycled fiber area. So if we look at the illustration here, it's a schematic of the recycling process, starting with a fiber-based packaging material. We have some kind of disintegration of the material, a separation where we can get, for instance, if it's a barrier in the packaging, we will have that in reject, we have the processed water, and we will end up with recycled fibers that can be used in new products. And we would like to focus on development of new characterization techniques so we can follow all material components in the different material streams. We also would like to look at how to manage the recycling process. So if we have a specific material, what will be the best process conditions to recycle it? And also understand variation of ingoing material. If we add something in the raw material or add some kind of functionality, how will that affect the recyclability? And also in the last theme, how to improve the performance of the recycled fibers so it can be used in new products and meet the required demands. Yes, and next slide. And today we have a recyclability test that we perform at lab scale, and it's based on the CEPI method. For those of you who are aware of this method, so it's for paper-based material. You have a standardized process with the different steps illustrated here with sample preparation, disintegration. We will have a screening, both coarse screening and fine screening. You prepare new paper sheets and evaluate them, the visual appearance, and also if there are any adhesiveness. And we can perform this test, and it's also the results of this test can be used to evaluate then if the material is suitable in a standard recycling mill. And also, if we look at the next slide, we also have the possibility to perform a recyclability evaluation at pilot scale. So this could be to optimize or demonstrate existing or future products. And here again, we have the raw material, and in that case, we work with recycled paper and board. We have a low consistency batch pulper. And after, we need to do some separation and cleaning of the pulp we can use pressure screens and hydrocyclones, and all again evaluation of sheet properties and the recycled pulp. Yes, and next slide. I would like to thank you for listening, and please contact me if you have any questions regarding the research program or the tests that we perform at Lab and Pilot.
Anna, may I ask you one more question?
Okay.
Please do. I was listening to your talk, and I was wondering, is there one breakthrough that you are really dreaming about?
I think there are many different things that needs to be combined in order to move on in this area. But I'm really looking forward to bring everything together, if it's all this packaging design, the recycling process, and so on. But I think it's difficult to...
What's the biggest challenge then? What's the biggest challenge?
I think the biggest challenge is to bring all of this together, to have a certain packaging design that will fulfill the required demands, and also how to have the sorting of the material, how to solve that, and also then to have a process at industrial scale that can take care of the ingoing material. Because there's a lot of variation of ingoing paper packaging material, and you need to adapt the process so it can handle all the different materials.
And at the end, of course, we want really good fibers. Yes.
Yes, so we can use them again, of course.
Of course. Thank you, Anna.
Thank you.
Okay, we're moving on. And by my side now, I have Mattias Andersson. Welcome.
Thank you very much.
Senior researcher at RISE. And now we're moving from fiber to plastics.
Yes, we are.
Go ahead.
Thank you very much. Thank you for that introduction, Niklas. So my name is Mattias, and I'm working as a senior researcher at RISE. In my daily work, I'm working with plastics and plastics recycling. I thought I should tell a little bit more on the situation that is plastics recycling and what we do at RISE on this. Yes. So the situation today, how does it look regarding plastics and plastics recycling? Well, today, roughly 40% of the plastic that's used today consists of plastic packaging. So it's a lot of the plastic that we use that are in packaging. And looking at the numbers, how we recycle this today, we can see that almost 20% of the packaging that are put on the market is recycled, made into new products. This number can be a little bit more positive if you also include the rPET system. And why is this important then? Well, in Sweden at least, the incineration of plastics constitutes over 90% of the greenhouse emission from the waste incineration. Think about that. That's a lot of greenhouse gases that are emitted by just incinerating the fossil plastic. So this is the situation that we have today. We have to really take care of this. We have to focus on how we can decrease this emission and to make plastic more circular. So how does the recycling of plastic looks today then? I show in this image, I think both Anna and Ann was also showing this circular economy of packaging. And looking a little bit on the goals that we have in Sweden for recycling plastic, it's around 50% that we want to material recycle to make into new products. Looking at this circular diagram that you see in front of you here, we can look at the end of this circle, let's say, if you can have an end on a circle. That is in the collecting part. So today, roughly 50% of all the plastic packaging put on the market is collected. That means 50% is not even collected for recycling. So there is a large amount that is not even reaching a recycling facility. And then looking at what's getting into the recycling facility, you can look at the circle with the green and yellow and red. This is from a picking analysis that has been done at Site 0 in Motala. And this shows you the green part here is the material that is actually designed to be recycled with high quality. And that's roughly 50% also of the plastic that comes into these sorting facilities. So we have a few challenges when it comes to plastic packaging then. As I say, roughly 50% of the plastic packaging is collected. 50% of these is today designed for high quality recycling. So by this number, I mean, the best we can do is maybe 25% real recycling, which is of course not good enough. And not good enough for the goals that we have set in Sweden. So we need to focus on a few things to make this better. One thing is, of course, increasing the collection rate. So one thing that we can work on there is to have a more close collection system, so it's easier to leave your plastic packaging in a recycling station. Another thing, of course, is that we must focus on the actual design of the packaging. And I'm saying design as a way of talking about what kind of material we're using, what colors are we using on the packaging, what labels, what prints are we using, what inks and everything. All of this have to be thought about when designing a packaging for recycling. And another way to increase the recycling of plastic and to decrease the incineration of fossil emissions is also to use recycled plastic in new packaging, which can be very difficult in some type of packaging, especially food contact application. So what we can do at RISE about these things, about this solution? So we have talked about design for recycling. So what makes a package recyclable? Well, here we can help with a few things. We can do material testing at first. We can investigate your packaging and the material in your packaging to see if it is actually recyclable. We can help looking at the pre-treatment, how you would wash it, how it's able to be sorted. And another thing is a question that we get a few times is also what material should I use and why should I use this material in my packaging? So here we can offer education and consultancy. So we can talk to us, and we help you, guide you through your process in deciding different parameters of your packaging. And we also have a good contact with Swedish Plastic Recycling, which we'll be hearing more about later on. And another question was then how we can increase the use of recycled content in plastic packaging. So first of all, is the question of where can I find this recycled material? Well, here we can help you with a network. So we have a wide range of producers of packaging. We are in contact with recyclers, sorting facilities, and also, of course, plastic producers. So we have a good idea of where you can find the different materials. And another one is, of course, material requirements. I mean, I talked about that we can do recycling tests, but we can also do then produce material data sheet that might be important for your decision on whether to use this type of plastic in your packaging. And the ultimate question, how to get food safe qualities. You will get more information about this soon today in a few moments. But right now, I want to mention that we also can be a research partner in such areas. So we can help you test new ideas, look at new approaches, how to actually get recycled material into food contact application. And also, of course, we do a chemical analysis to find out if there are any harmful substances in these plastics. Yes, I just want to give you a quick example before I finish my presentation. So this is an example that is a project where we look at design and testing for recyclability or recycling. The project was called CircPack, and it was about to increase the recyclability of high barrier flexible packaging. So this was a project together with the industry, and we had everyone from recyclers, brand owners, packaging producers, and of course the research institutes in this project. And here we were looking at this what's called multi-laminate films, where you have, for instance, you have a polyethylene and maybe PET as a barrier material. When you mix these two and you do recycling, you will get the image that you see on the left-hand side here. Not very high quality plastic, not very good for doing a new film. But there are other alternatives, such as monolaminated films, where you use another type of barrier, for instance, EVOH, which is more compatible with the polyethylene in this case, which makes it possible to produce a film that you see on the right-hand side, a transparent and working film. However, we find some challenges in this project as well. There is a lot of components in these films. There are these barriers. We have adhesive that used to glue this material together and so on. And very interesting with this project is that I saw now, I think it was a month ago, that Mondi and Scan Sverige, which was part of this project, and now put on a new package using this kind of material that we were investigating in that project. So this is a way to design for recyclability and also test the design. And with that, I'd like to thank you very much for listening to this, and I'm happy to receive any questions, and maybe Niklas, you will talk a little bit what will happen tomorrow. So thank you.
But I have a question to you first.
Yes,
because I'm not really familiar with this packaging and plastic lingo, and you use the word incineration.
Yes. That's burning the plastic.
Burning the plastic.
As some people say, it's burning the plastic to generate energy. So when it comes to waste, most of the waste that goes to incineration is plastic, and that's or the fossil part of it is plastic. So that's why the stated 90% is of the emission comes from there. So
we don't want to do that.
We don't want to do that. No.
Thank you, Mattias.
Thank you.
And it's time for me to welcome another co-worker here at RISE, Hans Steyer. Welcome, Hans.
Thank you.
Walking into the studio, you're a project manager at RISE, and we'll be talking about recycling into safe materials.
I hope so.
I hope so too.
Yes, my name is Hans Steyer. I work mainly in something called Normpac. Next slide, please. And that's me. Okay, thank you. Well, I'd like to start with an image that comes from the EU Commission's Working Group for Food Packaging Materials. The view on recycling of materials is still largely this within the EU. It's garbage. Smelly, unsorted garbage. To be treated in a process that turns it into such clean material again that it's possible to package water. Water that must be so clean that it can also be used to make breast milk substitute. And the requirements, of course, then on the recycling technology are high. The picture in Sweden is perhaps a little more nuanced. There are, for the most part, as we heard about, functioning deposit system for drink bottles. So the starting material when recycling PET is not garbage. It's a sorted fraction of basically bottles with some leftover drinks only. But back to the title then. Recycling into safe materials. What are safe materials? Safety when you use a pizza box is something else than safety when using a chair or planting your plants in a pot. So in short, I would like to convey then what safety is related to the intended use. Of course, you also want the product to be stable during the use and thus not affecting the pizza, or the chair should not give you a rash or collapse. And after the use, the needs might be different, with possibility to degrade or to recycle the material again, preferably. But however, I would try to limit the discussion to product safety. When recycling materials, these may contain unwanted substances, and as Rickard pointed out, they can be formed during recycling as well, and with different level of hazards. But the risk might be all the same but tolerable if the exposure to those substances are evaluated and controlled below a limit that is found to be safe. And what are the potential hazards then? Since I work mainly with food contact materials, chemical residues are what I mainly think of. The materials like plastics degrade during production, use, and recycling. For example, may antioxidants added to the plastic degrade, which is expected. Also, a mixture of different components like additives and colorants might react during the lifespan of a product. There might also be contamination of unwanted substances during the use, or rather misuse. Hygiene is also important, of course, that the recycled materials end up being microbiologically safe. An important aspect is the odor or color of the recycled material. Also, the taste of a packed food might potentially be affected of the recycled material, perhaps not always a severe hazard in all cases, but all the same making the material unfit for the purpose. Back to the question then to what is fit for the intended use, also after recycling. I think you all have heard about the concepts of upcycling or downcycling when recycling materials, meaning if the material is used for more or less demanding applications after recycling. In relation to safety, I rather want to see recycling as the main track. The materials in a car, a sweater, or a bottle are perhaps best used if returned to the same use again. Again, with my perspective from the food packaging sector, recycling of a food contact material in principle starts with sorting of materials. Exactly that, food contact materials. And the recycling of these deal with the handling of potential contamination. The actual composition of the bottle has already been assessed and assured as a food contact material. The same applies to the textile and automotive sector, I guess. The materials should be designed with the right or suitable composition for recyclability from the start. And important enough, traceability to be able to sort the material will be more and more important. And again, if I may take some examples from my field of food contact materials and how the work with safety of recycling of materials is done today. Mechanical recycling of plastic materials is in principle still only possible for PET, even if there is a new legislation in place saying how to deal with innovation of new recycling technologies. PET recycling today relies on sorting and cleaning, then a decontamination process capable of removing chemical contaminants regardless of what they might be. And then depending on the outcome of the whole chain, there might be restrictions in the possible use. For recycling of fibers from paper and board, it's a similar workflow, but here monitoring of some common contaminants has replaced the decontamination step. It's also possible to use a barrier in the final construction to limit the exposure to contaminants. And as for plastics, restrictions in possible use is also part of the risk management. So even if you may say it's a way of downcycling, meaning that the quality of the material is lower than for new materials, the use is still for packaging of food, even if it's more restricted. For example, only at the lower temperatures or only for dry foods. We talked about the risk with recycling materials, but these may be managed. First of all, used materials is a valuable resource, not garbage, as I see it. I touched on how to deal with chemical residues. For dealing with hygiene and microbiological risks, often the decontamination or recovery process is also enough for dealing with these risks. The organoleptic aspects, like odor from the materials, might be harder to handle, since our perception of this is so sensitive. Therefore, this might be the limiting factor in the end for the use of certain recycled materials. RISE may help out in several areas of what I've talked about. We may evaluate exposure of chemical residues through chemical analysis and toxicological assessments. We have capabilities in microbiology and also in perception, and therefore we can help out in recycling to safe materials. Thank you.
Thank you, Hans. That's great. May I ask, in your daily work, what are you looking at right now?
In this field, we try to keep track on the discussion what's going on the EU level.
Yeah.
As I said, there's a new legislation for recycling plastics. At least it has set the scene or the playing ground for how to innovate more of recycling more fractions of plastic food packaging. And we hope very much that will be successful. We heard that it's slightly more than 20 such new technologies that have been sent into the Commission, but we haven't really seen any details on them yet. So we're curious.
Yes, curiosity is good. Yeah, right. Thank you. And speaking of curiosity, I'm sure that many of you have many more questions. And tomorrow, our experts that you have heard here today will be available for exactly your questions. Maybe you have questions regarding your own operations or something that has been said here today. I think we will have a sign showing the link for you to join tomorrow. There. So open time for questions and discussions tomorrow, Thursday at 2 o'clock. Is it Central European time? Yes. 2 o'clock Central European time. Anna, Matthias, and Hans will be available for your questions and discussions. And with that, I will thank you all for listening and watching today. And we hope to hear from you again tomorrow. Bye.